So we start Minikube. We have in the Minikube deployed our Spark cluster, small cluster. This cluster can be accessed through the. You can check it with the web UI. We have web UI where we see two workers, one master, and also we create what we have also. What about another things we can do with our Kubernetes cluster? Also, we can check our web interface, because we can see the web interface of our Apache Spark. We forward the port, and we can see how it we see two workers. We can see all computer applications if we have them. If not, we can see that we have 6.7 memory. And the next important task we have to do, we have to run our application. It's not something complicated, but it's rather simple. But we have to produce a few steps for this. And what we will do? We will do for this. We will do. At first, we set some variable, example jar. In my case, we have this directory. Now we can check this directory with pass variable example jar, and we see that we have these jars here. And now we can run our example. It will be rather simple. We have command kubectl exec -ti -namespace. In our case, we have only default, but better to use some appropriate namespace for some services. We will do it later, a bit later. And then we add, we said that we have Spark worker. And maybe I copy paste the rest of this command, not to type by myself. So we have some Spark worker. We pass, we run the command spark submit. We send it into Spark. And this is the port inside our Kubernetes. And we have class, and we have this example. Also, we can see that we run simple program SparkPi. Then I run this command, and we see that it is running. It's submitting our command. And we can see that we obtain the value. Pi is roughly 3.14. So we have our value of pi, which is example application, successfully executed, and we obtain the result. So it's rather simple. It's rather simple to start Spark cluster with a Kubernetes, and we can check the results of execution of our program execution Here we see that we have application ID, and we have one executor ID, and we can check we can check std output error, and we theoretically can check also std out, but what is the issue? We can't access to this port. We should also forward this port to access to this port, and in this case we can access it through our logs of our Apache Spark. This is the main ideas how to run it with application Spark, and also we will talk about one technology which we use to deploy our Kubernetes into Spark. We use about Spark into Kubernetes. We will talk about Helm. I didn't deploy this Spark manually. For this purpose I used a Helm chart, which is some prepared script maybe, or some code which describes how this code should run in our cluster. And for this purpose I use so at first you should install in your computer. We click here get started, and how install Helm. We should read how to install it. It's rather simple, because we have very simple script, and we have possibility. We have to install first Choco and then install Kubernetes Helm. If you are using Linux or Mac, also we can install it with a brew or on the bind with the apt. So we install Helm. So installation of utility is rather simple and described well here. And then we have this Helm chart. I used this Helm chart to run our Spark cluster, and we have here small description about this Helm chart, and this Helm chart simplify the task of deployment. You see that you simply add repository, then install only two commands. Install your release, name of your release, from this repository Spark, and that's all, and you have Spark cluster already installed. So two commands to simplify everything. So I suggest you to use this option, and you will obtain the same cluster like in my case. So it's rather simple. Also, you have to understand that you have to have installed Helm. Yes. How you can check it? Helm, yes, and we have ability to search some packages. We have ability to, for instance, Spark, yes. Repo. And we can search for some repository if it's available for us, and we see that we have this repository in our case. Yes, it's already added and installed, and we see that we have Spark, the fast and general purpose cluster, and etc. So we have ability to use it. Also, we have all the versions of it, so I show for you it. I suggest you to use this repository, because also we have in this repository Apache Kafka, a great streaming platform, and you can download it here, the latest version of the Kafka. So this is what I suggest you to do, and I suggest you to at first install. So the steps you have to okay, let's do it together again. So we have, I stop everything, I do Minikube delete minus all, sorry, oh, and again let's look here, Minikube delete all. No, in general I type everything right. Okay, let's ask him Minikube delete. Okay, we delete it without any specific options. So we have a Minikube status, and we don't have anything. The first step you should, okay, at first we should, what we should do, let's do it together. And again, what we should do, at first we should install Minikube. We should install Minikube in our computer. We can do it from official site, and we have, but for Windows we have to install Chocolate. For Linux we have a bit different way, but it's also simple. And for Debian or Ubuntu we have dep package, which is simple to start and install, and we have few base commands. So at first, to start our cluster, what we have to do, we have to type command after installation of Minikube. What we have to do, and again, what is Minikube? Minikube is implementation of Kubernetes cluster. Kubernetes, which is a cluster which is based on containerization. At first, what we are doing, we start Minikube, but start Minikube not with default configuration. We have to use some extended configuration. I suggest you to set larger amount of memory and CPUs, because by default you will have 2 CPUs and 2 or 4 gigabytes of memory. I suggest you to set this value to 4, and memory for instance maybe about 10 gigabytes. And then you also, I want to show you that what you are doing. Indeed, in my computer, my Minikube configured that it will start some virtual machine inside VirtualBox. So I show it for you. You have VirtualBox. Yes, we have this VirtualBox, and what we are doing, we have this VirtualBox. When I type Minikube start, we have, you see, starting local Kubernetes cluster, starting VM. And if you look inside our virtual machine graphical user interface, we see that appeared new virtual machine with the name Minikube, which now is powered off. Now it's running, it's starting. And if you look at the configuration, you will see that we have it's rather small amount of memory. That's why our cluster, I believe, will start with a very high speed. Sorry, I missed the value of the memory. I have to increase. Okay, in this case we will see how we can deleted successfully from starting VM. Let's give it possibility to start. Getting VM IP address, moving files into cluster. They starting cluster components, and we see that the system is running. System is running. System is running, but I suggest you not to start with so small amount of memory your cluster. I suggest you to use more memory, especially for Spark, which is memory oriented framework. I suggest you to increase the number of CPUs and the amount of memory you have to use for your Spark cluster. And also, what is advantage of this approach? The approach of using Kubernetes allows you to migrate successfully without any additional concerns from one cloud to another, from Google Cloud to Amazon, from Amazon to Microsoft Azure, and it allows you to spend less money for cloud computing. Depends on needs of your business. For instance, Google Cloud is less expensive than Amazon, and Amazon is less expensive than Microsoft Azure. And now you see that we have it. We can check kubectl get all, and we see that the cluster started. kubectl is a command which we have to use for testing and checking that everything is okay. And now let's start. Oh, it's too rather slow. Also, we can see how the network is configured. We have host-only adapter with some internal network. We have NAT. We have 20 gigabyte, about 20 gigabyte virtual hard drive, and 1 gigabyte of memory. That's why the system run is run too slow. So we have this cluster, and you see that we don't have anything in our cluster. Okay, let's, and again, sorry, Minikube, delete. We deleted our cluster, and we set, okay, let's check virtual box again. Yes, you see that it was successfully deleted. Now let's create again, but with larger amount of memory, maybe 8 gigabytes, about 8 gigabytes. And you see that in our virtual box, create a new virtual machine with the new settings. And now, okay, let's check again. Starting. It's starting, and the next task is to The next our task to run our Helm chart. It's starting. Virtual machine appeared. Configuration is set properly. And now let's move to our Helm chart and let's check it. Okay, let's look on the Helm. What is Helm? Helm repo list. Previously I add this repository. By default, after installation of Helm, repo list gives you information about your available repositories, and we have by default this repository, and you can add these two repositories were added later. So now the first step should be adding of new repository. It should be command something like this repository. For instance, let it be 2. We add second, and now we see that we have it. Sure, I have to remove this repository. Yes, the command remove one more chart. I'm doing remove because I don't need two same repositories. Sorry, this one. No, repo bitnami 2. Yes, it was successfully. Yes, you see, I deleted it successfully. We have this repository successfully added. Now we check our cluster. It's starting, and in a few moments it will be successfully started. Then what I'm doing, I'm installing Apache Spark into, yes, it's started now. We can check it. kubectl get all, and we see that our cluster successfully started. kubectl successfully started. Yes, we can also run command kubectl cluster info, and then we will obtain some information about this cluster, because internally Kubernetes has its own DNS. Now let's do the next. And now the next good idea is to create some namespace. Let's create namespace Spark. Namespace created. Also, let's run dashboard for our Kubernetes, and now I'm starting it for our Kubernetes. Better to start dashboard, and now in our browser we will see this dashboard. Let's check it again. Let's look on it, how it looks like. So we have clear system, yes, without anything. We see that we have service Kubernetes, it's internal service. We have some IP addresses. We have nodes, it's basic nodes of Kubernetes. We have some consumption of resources, and we have namespaces. So we have default namespaces. I created just now a namespace default. Where it was? Yes. So I created just now a namespace Spark. Why we are using namespaces? Namespaces are very natural to separate our application. Depends on their usage. So at first we create this namespace, and the next what we will do, we will install. So with the Helm we will install, but let's check how we can install it. We have some flags. Naturally use these flags to check that we have this namespace, and it will be simpler for us to use it at all. So let's move forward. Let's set or use some namespace. At first you should understand that we have let's use namespace. Okay, also let's remove. Okay, maybe let's do it in this case. Sorry, Helm, install namespace, maybe Spark 3, and then let's put here the name of our installation. The name is 301, it's the version and repository where from we install it. Okay, let's try. Okay, without namespace, because I see that. Let's install it without namespace, but better to use it all. Oh, sorry, not create namespace. I should put here namespace. Okay, if I install, I can uninstall it. Yes. So maybe if you need it, we can and let's set that we have we want to remove this installation. Install minus uninstall Spark -301, and now we uninstall our also if you look here, it installed successfully. Better to show you how we install it, but okay, what we are doing, install, but later we set our namespace. Namespace will be Spark. So we created before a namespace, then we install Spark 301 into this namespace. Now let's check web UI. You see that we have this namespace. This namespace, it's active. Also here we have namespaces. Now we have two namespaces, default and Spark. We choose for instance namespace default, yes, and we have Spark. We choose Spark, and we have installed in Spark these things. We have master, and it's container creating. It's a process of creation of container. So the process of creation, now it's only creating our system. We can look into the logs. So now it's only creating, and then what we are doing after our application is created, we can you see here we have this example here. What we have to do, we have to forward the port. In my case, I forward it into port 8080. Also, we can forward another ports. Okay, then what we have to do, we have to export these parameters. Just a moment. Now export these parameters, and here we see that we are running our Spark application. Sorry, not this one. And then we put here example jar, and this is parameters of our application 5. Then we start execution. You see that we have submitting 5 missing tasks. It's trying to run this application. Running. Indeed, we can submit any task we need, but we have to remember that we should provide preferable ports for this application if you want this application to be successfully executed. So this is what we have to do. So our application running, and we obtain the result. Yes. In web UI, we can check how our application run. This is the application. It was finished just now. This is the time not from, we have to take into account time zone, which is inside our cluster, about our Kubernetes cluster. And we see that now our Spark Kubernetes cluster, yes, it's green because it's running, so all of these resources are consumed. So this is what we did, and we run our test application. It was rather simple. So with this step we can finish with the basic ideas. What we have to do at the end, we have to we can simply do delete. And after this, all of our experiments, you see that our virtual machine was deleted successfully, and we don't have anything now. So we finish with our laboratory work. Simple, rather simple. You saw utilities like Helm. So let's make a small summary what we do to reproduce the same. At first, you should install Minikube. This is Kubernetes cluster on single machine. Second, you have to install Helm. Yes, we have to install Helm. So installation is properly described of Minikube, described here, and Helm is described in official site of a Helm, and depends on your operating system. You will use your own installation. Then we have to create and start our cluster. What we are doing, you are running a command. Let me copy and paste this command simply from command line prompt, because it's rather simple. I don't want to type it twice. And again, I remember that we used then we what we are doing, then we install, we check installation with the command minikube status. Yes, and we can run kubectl cluster info kubectl get all, and etc. There are much more interesting commands here. The next stage, our stage, is to install our Helm chart. To install our Helm chart, we have to add first repository of our Helm, and this repository will be also, I forgot that we also using we create namespace. To create namespace, we also use additional command Let me copy and paste. This command for you. At first we create namespace Spark. We create this namespace and then we install Helm chart of Spark 3.01 into Kubernetes, into mini or Kubernetes, let it be Kubernetes. And then we the command to install, we are using Helm install. Oh, sorry. For this, first we add repository. Yes, we have to add repository. We have to add repository with the name we have to add repository with this, with the Spark, yes, and install it. Also, when we start our repository, we start our cluster, we should wait, check status of Spark creation. The simplest way to check with the web UI, so simply type Minikube dashboard and check then you can submit your Spark application. It's rather simple. At first you by calculation application. The first command and second one. Maybe remove, okay, this, this, and this. Then what we are doing, check status of execution. And also forgot, first maybe this will be 10, but 9 will be what we should do. We should port forward of cluster of Spark Web UI. To do this, we're doing something like this. Let it be this. Here is the port we can access. First number is the number of the port we can access locally. So visit web browser on port this. Check status of execution. This is the check. Okay. Okay, this is the check. And the last step is delete our cluster. With the command minikube delete. Also we have stop, possibility to stop, because delete or stop cluster. What is the difference? The difference that if you don't want to delete everything you created before, you simply want to stop execution of it, do the stop. If you want to consume less resources, minikube stop. So this is what we was doing. So that's all we have to do to run our Spark application in Kubernetes.